Chapter 7, Transverse Shear, Shearing Strength. We want to solve a problem in which we have 5 identical rectangular boxes. In scenario 1, they are stick together with glue, and in scenario 2, they are just located top of each other without anything. And each of the cross sections is A. So let's solve the problem. In scenario 1, we want to know what is the ratio of shearing strength in scenario 1 with glue over without glue. So in scenario 1, we do have tau maximum for a rectangular cross section. If you remember, H, that's a tau max is equal to 1.5 shear, vertical shear, over the area, which is B times H. So in this case, when we stick the boxes together, the whole cross section acts like a unified cross section with the area of 5A. Each of them are A, and that's a 1.5 V, which is vertical shear, equal to P in our case, over A total, which is 5A. If you solve it, it's a 1.5 P over 5A in scenario 1. And in scenario 2, which is when we just locate the boxes top of each other, each of them has a cross-sectional area of A, and we don't use any glue in this condition. So tau maximum is equal to a 1.5, again, vertical shear over the area, and it just as if we are dividing the shear amongst each boxes, because they are not stick together. The share of shear for each box is P over 5. So this time V is P over 5 over each of the cross section, which is A, and that's again a 1.5 P over 5A. Shearing strength has a relation with inverse tau maximum. We'll talk about that later on. And in such case, tau maximum 1 is equal to 1.5 P over 5A. Tau maximum 2 is 1.5 P over 5A. So at the same time, shearing stress is 1 over tau maximum in case 1 to 1 over tau maximum in case 2. They are equal to each other, so the inverse relation of them are also equal to each other. So the ratio is a numeric value of 1. Let's solve a different problem. In this problem, we have two beams have the same cross-sectional area. So area is equal in both of them. One is rectangle and the other one is a circular cross section. We want to calculate the shearing strength ratio of a circular shearing strength over the rectangular shearing strength. So let's solve the problem. So shearing strength is again has a relation with a inverse tau maximum. So if you remember from a box or a square, shear maximum is like a rectangle. That's a 1.5 shear over the whole area. And if you remember from a solid circle, tau max for a circle is 4/3 of shear over the area. So again, shearing strength has a relation of to a inverse tau maximum. So shearing strength of circle to square is tau maximum of square over tau maximum of circle, and that's a 4/3 over 3 over 2 over 4/3, that's 9 over 8. So the strength ratio of the uh, circular cross section with the same area to the square one is 9 over 8. Interpreting the shearing strength and its relation with one inverse 1 over tau maximum is that interpretation of shearing strength formula, it means any beam which has a smaller shearing strength has more a smaller shearing stress has more shearing strength. So how that goes? In other words, the beam with a smaller tau maximum, so tau maximum shearing strength, uh, let's put it this way, shearing strength has a relation with 1 over tau maximum. It just simply says any beam which has lower tau maximum has higher shearing strength. And the interpretation of that, if the beam with a smaller tau maximum, as you reduce tau maximum, the beam has more capacity to handle more shear. Hence, the higher, so uh, having higher shearing strength. So that's the reason behind inverse relation between tau maximum and shearing strength. Thank you.